Hi everybody. Today we are going to start Unit 5, Properties of Triangles. I'm sorry I can't be there with you today, but luckily I have these videos so you're not missing out on any of the notes. So what I'll have you do today is watch this video and then I want you to try the questions on pages 6 and 7 for homework, which we'll go over tomorrow. All right, so a perpendicular bisector is shown in this picture here. It's a line that's perpendicular to a segment, which means remember that it just forms 90-degree angles at its midpoint. So that means that it's cutting it right in half. It's running right through the center. So you try, draw OK, it's line segment OK. And then we want to draw a line M that is, I don't know why there's two that's perpendicular. That is the perpendicular bisector of it. Okay, so again, if it's the perpendicular bisector, it's going to run right through the center. It's going to be perpendicular, so it has the 90-degree angles, and it's bisecting it, so it's cutting it in half. And that's line M, so we're going to label that. An angle bisector does the same thing, but to an angle. So it's a ray, term you haven't seen in a bit, that divides an angle into two congruent angles. So in this picture, we have angle LJM, remember, follow the path, and ray JK is cutting it in half. So this angle is the same as this angle. So go ahead and draw that. Draw ABC, angle ABC, follow the path, A, B, C. You don't want to pick up your pencil when you're drawing an angle. Then you want to draw ray BX, that is the angle bisector. So here's the B, X, and it's cutting it into two congruent parts. All right, another term you'll see quite a bit this chapter, equidistant. Well, the first part of that just means equal distance. So when a point is the same distance from two or more objects. All right, so just some quick angle review. We haven't talked about this since chapter 1, but name 3 angles in the picture. When you're naming an angle, make sure you put the angle mark. All right, the symbol there. If we look, we can't just say angle W because there's 3 angles there. So let's look at the big angle first. XWZ. Or ZWX, it doesn't matter, but the W, the center, your vertex needs to be in the middle. All right, let's look at this angle. Angle XWY. Again, following that path. And then YWZ. All right, it says if ray WY bisects angle XWZ, which 2 angles are congruent? Well, these 2 are congruent. So angle XWY is congruent to angle YWZ. All right. So now draw an obtuse angle CAT. All right, obtuse, so it's going to be bigger than 90 degrees. Something like that. CA is your vertex. It's in the middle. And T. Draw the angle bisector AS. So it's going to be a ray that starts at A and goes out through S. And it's cutting these into 2 congruent angles. So which 2 angles are congruent? That's an S. Can't even read my writing. Angle CAS and angle SAT. All right, we're going to skip 4. Just remember that the middle letter in every angle is the vertex. It's the point where the 2 rays meet. Okay, so now let's talk about the perpendicular and angle bisector theorems. The perpendicular bisector theorem, basically if you have a perpendicular bisector, which we can tell from this picture because it has a right angle, it's cutting these in half, any point on the perpendicular bisector, X, is equidistant, the same distance from the endpoint. So what that means is XA or AX is the same as XB or BX. And I'll use 2 marks because they're not the same as these. Basically what's happening here is you're looking at 2 mirror images, right? Everything on this side matches everything on this side. The converse of that, converse just means the opposite. If a point is equidistant from the endpoints of a segment, it's on the perpendicular. So basically, if these are the same, it's telling us that this is perpendicular and these are the same. All right, it's actually pretty easy. So in this picture, it shows us right here that it's a perpendicular bisector. You've got the right angle and the two congruent sides. So it's looking for YW, which is this side. Well, if this side's 7.3, so is that. Simple. Everything matches. On the next picture, it shows us 36 and 36 are the same. That means that 16 and 16 are the same. So if you're looking for BC, the whole thing, 16 and 16 is 32. All right, if there's variables involved, this is about as hard as it's going to get today. You have a perpendicular bisector, so these sides are the same, so just set them equal. You're not going to be setting them equal to 180. They're not angles. And if it's easier, put the larger variable on the left. So this side is the same as this side. And you could also write 2n plus 9 equals the 7n minus 18. Doesn't matter. All right, so let's solve this. We'll subtract the 2n over. 5n minus 18 equals 9. Add 18. 5n equals 27. And then divide by 5. Calculator doesn't want to work right now. That's okay. 27 divided by 9 is, or by 5 is, 5.4. But it's looking for PR. So PR is 2n plus 9. So 2 times 5.4 plus 9 gives us 19.8. All right, so if you want, pause the video right here and try these. All right, so given that line L is the perpendicular bisector, so we know these are the same and these are the same. EG is 14.6. What's DG? You guessed it, 14.6. They're exactly the same. Both halves are the same. All right, with this it says DE is 20.8, so that's that whole distance. DG is 36.4, and EG is 36.4, so we're looking for EF. Well, if that's cut in half and that's 20.8 divided by 2, 10.4. Easy. All right, let's move on to the angle bisector theorem on the next page. So the angle bisector theorem does the same thing, but with an angle. So if a point is on the bisector of an angle, then it's equidistant from the sides. So that just means since this and this are the same, these are the same. In the converse, again, the opposite's true. If you have two, or if a point is the same distance from two sides, then that means that that's an angle bisector, and those angles are the same. So again, it's just like before, the two sides are exactly the same mirror images. So if JM is 12.8, LM is also 12.8. Over here, the measure of ABC, that's the whole thing, is 112 degrees. What's the measure of ABD? Well, if you look, this is telling us that those lengths are the same. So that means that these are an angle bisector. So if you just do 112 divided by 2, you're going to end up with 56. And it's an angle, so degrees. All right, just like before, since these are the same, these angles are the same. So set them equal. 6z plus 14 equals 5z plus 23. At any point, if you need to pause the video if I'm going too fast, you can. That's the nice part about watching these notes. So we'll subtract the 5z. 6z minus 5z is 1z or just z. Plus 14 equals 23. Subtract 14 And we have z equals 9. But again, it's not looking for z, it's looking for the measure of angle TSU. Follow that path. So just this half, 5 times 9 plus 23 is 68. It's an angle degrees. All right, last question on that. The measure of angle WYZ. Oops. WYZ. So we're just talking about this is 63. And it says that XW and ZW are both 5.7. Since those are the same, that tells me that these are both 63. So if we're looking for the measure of angle XYZ, it's the whole thing. So 63 and 63 gives us 126. Okay, so just a couple practice to try in class. First period, they took some time to try these on your own, so this might be a good time to pause the video and do that as well, and then check your answers. But with this one, since these are both 14 by the markings, these are both 16, so RT is 16. Over here, since these are the same, it's looking for AB, the length of this whole thing. That means that these are the same. 2.5 and 2.5 is 5. Over here, since we have a perpendicular bisector, we can tell by the markings. We know that these are the same. So 5x minus 3 equals 3x plus 1. And solve it. We'll subtract the 3x over. 2x minus 3 equals 1. Add 3 to both sides. 2x equals 4. Divide by 2. X equals 2. So if you want to find HJ, that's this guy right here. 3 times 2 is 6 plus 1 is 7. All right. And at the bottom, dealing with an angle bisector again, matching parts are the same. So if that's 18, that's 18. If this is 23, this is 23. It's looking for EH, 23. Over here, since these are the same, these angles are the same, so that's 26. QRS, it's looking for the whole thing, 26 and 26 is 52 degrees. And then the last one, again, you guessed it, since these are equal as well. 4x minus 25 equals 2x plus 5. Subtract the 2x over. 2x minus 25 equals 5. Add 25. 2x equals 30. Divide by 2. So x equals 15. And if we want to find the measure of WXZ, let's follow the path. WXZ is just this half, not the whole thing. 2 times 15 is 30 plus 5. 35 degrees. Okay, so that's it for notes. Homework is page 6 and 7. Just so you know, I drew a second picture for number 2. These are independent of themselves. So EH is 100 in the first question, but in the second question, it's not the same. So, you could either label your picture over here and figure it out and then cross it out and do the next one. Same thing with 3 through 6. You're using this picture right here, but they're independent of each other. So, these values are what they are for 4, but they're not the same with the others. Same thing with 7 and 8 with that diagram, and 9 through 12 with that. And then on page 7, just 2 questions with lots of space to work. Well, a few questions on that one. All right, make sure you show your steps. Don't just put down answers. And then tomorrow, we'll get into some new terms you haven't seen. If you have questions, stop by the Math Lab. Have a great day.